Hi, everyone. In this video, we're going to look at more examples using permutations and combinations, except we're going to be using the permutation and combination formula to solve slightly more complicated combinatorics questions. Okay, so our first one is this. A team at a company wants to create a committee with 3 men and 3 women. If there are 7 men and 8 women on the team, how many committees can be formed? And so for all of these questions today, we're going to want to use the multiplication rule. Okay, and we're going to be using it in a slightly more complicated way. But the idea is we still want to break everything into tasks. And so here, task 1 might be select the men for the committee. And task 2, select the women. And now, so the only difference, right, the multiplication rule, we're going to find how many ways to do task 1, find how many ways to do task 2, multiply those numbers together, and we'll get the total number of ways to choose the men and the women. Because choosing the committee amounts to choosing which men you're going to use or have and which women you're going to have. The difference is now selecting the men and women, each of these tasks is not as straightforward as when we first learned the multiplication rule. So for selecting the men, how do we do this? So let me give us some more space here. So for selecting the men, we have 7 men, and we want 3 men on this committee. So does the order matter? Well, the answer is no, because again, there's no notion of a ranking. It's just selecting which people are going to be on it. It's not, there's no indication that it matters which order they're selected. And so we're going to do a combination. So the number of ways to select the men for this committee, well, we have 7 men. We want to select 3 of them. We want to choose 3. And so we're going to do 7, choose 3. And so that's 7 permute 3 over 3 factorial, which is 7 times 6 times 5, divided by 3 times 2. 3 times 2 is 6, divided by 6. We're left with 7 times 5, which is 35. So there's 35 ways to accomplish task 1, which is selecting the men. Now, selecting the women is the same thing. We have to do the permutations and combinations. So if there's 8 women on the team, we want to select 3 of them. And so the number of ways to do that is choosing 3 things from a set of 8 things with no ordering. That's going to be 8, choose 3, which is 8 permute 3, divide by 3 factorial, which is 8 times 7 times 6, divided by 3 times 2. Again, 3 times 2 is 6, so we can divide this 6 by the 3 times 2 and get 8 times 7, which is 56. So selecting the women, so for task 2, we have 56 ways to do this. And so the number of committees that we can form, this is the same as the number of ways to select the men and then select the women. And by the multiplication rule, this is the number of ways to do task 1 times the number of ways to do task 2. So that's 35 times 56, which is 1,960 ways. Okay, so that's the number of ways to select the committee. Okay, and the difference here is we can't just say, oh, there's 15 people on the team and we need to select 3 men and 3 women, because these 3 men have to come from this group of 7. These 3 women have to come from this group of 8. And so we break it up into 2 separate things like this. Okay, this one's a little bit more complicated. So you are going on vacation. You own 13 shirts and need to pack 5 of them. You also want to plan which trousers you will wear. You need to pick a pair to wear on day 1, a pair for day 2, and so on. If you own 8 trousers and so on, for 5 days. We're assuming we're wearing one shirt and one pair of trousers per day. If you own 8 trousers, how many ways can you do all of this? And so here we have two more, we can break this into 2 tasks. So task 1 is to pick your shirts. Oops. And task 2 is to pick trousers. Okay, so for picking shirts, it doesn't say you're going to plan for the shirts. You're not planning which one you're going to wear on which day. You just need to select 5 of them. And so this is a combination. You're just saying, I'm choosing which 5 am I going to take and not indicating an order. And so this order doesn't matter. And so we're looking for a combination. And so when we're doing this combination, we have 13 shirts. We're choosing 5 of them. So that's 13, choose 5. That's 13 permute 5 divided by 5 factorial. So that's 13 times 12 times 11 times 10 times 9 divided by 5 times 4 times 3 times 2. And I won't bother writing the 1. Okay, so one thing I can do is, I see I have a 4 and a 3. 4 times 3 is 12, and I have a 12 up here. So if I can't divide the 12 by the 4 and the 3, those will all cancel. And I have a 2 and a 5 left. 2 times 5 is 10, which cancels with this 10 up here. So that leaves me with 13 times 11 times 9. And that's 1,287. So for picking shirts, I have 1,287 ways to do this. Now, picking the trousers is different. You're picking one to wear on day 1, one to wear on day 2, one to wear on day 3, and so forth. So you're giving an order to this. You're saying, I will wear this one first, this one second, this one third. You're making this decision in advance. And so there's more ways to do this. So order does matter. Because again, you are picking in advance, I'm wearing this one first, this one second, and so on. And so that means, because the order matters, we're using a permutation. And so we're going to do, we have 8 trousers. We need to pick 5 of them in order. So that's 8 permute 5. So 8 times 7 times 6 times 5 times 4. Because this is the first 1, 2, 3, 4, 5 terms of 8 factorial. So if I put this into my calculator, we get 6,720. It's a lot. Okay, and so to pick your trousers and the order, which is what we want to do, there's 6,720 ways. And so the total number of ways to pick everything, well, it's the number of ways to do task 1, which is 1,287, times the number of ways to do task 2, which is 6,720. This is going to be a big number. So we do this multiplication, 1,287 times 6,720. That's 8,648,640 ways. And the reason this is so large is partly because we have this permutation here. We're combining a permutation and a combination. Half of these decisions involve a combination, and the other half, because we've got an order to it, we're picking an order as well as we're picking which trousers and which days to wear them. That's an ordering, and so that's upping our number. Okay, a student council has 8 seniors, 7 juniors, 9 sophomores, and 11 freshmen. A committee is to be formed consisting of 3 seniors, 2 juniors, 2 sophomores, and 1 freshman. How many ways can this be done? So this is potentially one of our most complicated ones yet, because not only are we combining the multiplication rule for counting with permutation and combination formulas, but we're also now increasing the number of tasks, because choosing this committee, there's 2 T's committee, I think. Choosing this committee is the same as choosing which seniors are going to do, then choosing the juniors, then choosing the sophomores, then choosing the freshmen. And so we have 4 tasks. Task 1, choose seniors. Task 2, choose juniors. Task 3, choose sophomores. And task 4, choose the freshmen. Okay, and in each of these, we're going to be using a combination because here we're just choosing them for a committee. There's no indication of we're picking this person first, this person is to be chosen first, and this person is to be the leader, this person is to be the next higher up. We're just saying we have 8 seniors, we want to pick 3 of them. And so there's no ordering. And so for all of these, we're going to be using combinations. So for choosing the seniors, we have 8 of them and we want 3 of them. So this is 8 choose 3. So that's 8 permute 3 over 3 factorial, which is 8 times 7 times 6 over 3 times 2. 6 is still equal to 3 times 2, so this is 8 times 7, which is 56. So there's 56 ways to choose the seniors. Now for the juniors, we have 7 of them, and we want to select 2. So we're going to be doing 7 choose 2, which is 7 permute 2 over 2 factorial. But 2 factorial is just 2 times 1, so it's just 2. So that's 7 times 6 over 2. Well, 6 divided by 2 is 3. So that's 7 times 3, which is 21. So there's 21 ways to pick the juniors. Now the sophomores, we have 9 sophomores, and we want to select 2 of them. Doesn't matter which order, right? Picking Alex and Betty is the same as picking Betty and Alex. They're both on the committee. The only thing that matters is who is on the committee. So to do this, so that means we have 9, and we're choosing 2 of them. So that's 9 permute 2 over 2 factorial, which is 9 times 8 over 2. You cancel 8 with the 2, so 8 divided by 2 is 4. So 9 times 4 is 36. Okay? So we have 36 ways to choose our sophomores. Finally, we need to choose our freshmen. We have 11 freshmen. We only want to choose 1 of them. So we're going to be doing 11 choose 1. So that's 11 permute 1 over 1 factorial. Well, 1 factorial is just 1, so that's just 1. So it's 11 permute 1. But 11 permute 1, that means we write out the first term of 11 factorial, but that's just 11. So 11 choose 1 is just 11. Whenever you're doing number choose 1, that's always just that same number. And so that tells us that there's 11 ways to choose the freshman. And that should make sense. We are only choosing 1 freshman. We have 11 choices, and so there's 11 different ways to choose. And so now the total number of committees, or the ways it can be formed, we're using the multiplication rule. Our first task, so the number of committees is the same as the number of ways to choose the seniors, then choose the juniors, then choose the sophomores, then choose the freshmen. Well, there's 56 ways to do that. Seniors, 21 ways to choose juniors, 36 ways to choose sophomores, 11 ways to choose freshmen. And so the multiplication rule tells us that we can just multiply all of these and get our number. So that's 56 times 21 times 36 times 11, which is 465,600 or 696. And so there's a lot of different committees that can be formed. Okay, so hopefully this has given you a little bit of a feel for how we can use these permutation and combination formulas when we're doing these more complicated counting problems. But that's going to be all for this video.